Hi there, Algebra 2. We're going to keep talking about our unit circle and our radian measures and our degree measures and those ordered pairs, those three pieces to the unit circle. I've included on Classroom a nice big unit circle. It's blank, so if you want to print it off and write yourself a really pretty copy of the unit circle, I know you'll appreciate that. You'll be coming back to that. And I don't know, you can laminate it, put it up on your bedroom wall. It's a nice piece of decoration. It's a good conversation piece. Everybody needs a good unit circle in their life. So print one off, fill it in, make it pretty, use lots of rainbow gel pens, and really enjoy that. Anyway, grab your copy right now. Today, our goal is to be able to go back and forth between radian measure and degree measure. It's important to note that these both, radians and degrees, both refer to central angles. We have it pounded into our head in geometry that angles are measured in degrees, but that's not the only way that they're measured. The idea of this arc length, whoops, sorry to shake the camera there, the degree, measuring an angle according to its intercepted arc, that piece of the circle, is also a way to describe the measure of an angle. And so today we're just going to be going back and forth. So if I asked you how many radians is 135 degrees? Well, you look for 135 degrees on the unit circle and you go, oh, hey, that's also 3 pi over 4 radians. Beautiful. How about how many radians is 240 degrees? Look for 240 degrees on your unit circle, and right there is 4 pi over 3 radians. And you're like, this is gonna be a snap. Can you go the other direction? How many degrees is 5 pi over 3 radians? Well, find 5 pi over 3 radians, and that is 300 degrees. Could you do negatives? Well, sure. What would the degree measure of negative pi over 6 be? There are two ways you can think about this. You can think negative pi over 6. Ooh, that's right there. Careful, you do not want to say 330 degrees because it was negative pi over 6. It's kind of like ignoring the negative and think, what is pi over 6 radians in degrees? Well, pi over 6 is 30 degrees. So this would be negative. If your radian measure is negative, your corresponding degree measure is negative. Now, negative pi over 6 would be coterminal with 330 degrees, but not equivalent. So that seems pretty simple as long as all of those pieces are on the unit circle. But what happens if I ask you how many radians is 55 degrees? Well, 55 degrees is not directly shown on the unit circle. It is on the unit circle. It's somewhere in between here, in between 45 degrees and 60 degrees. And so we would expect that our radian measure would be somewhere between pi over 4 and pi over 3. But how exactly do we find that? That's what we want to look at. You probably want to grab your notebook and write down these few examples. I said 55 degrees, so I want to look at 55 degrees and I want to change that into radian measure. The key to that is back on the unit circle, finding a spot on the unit circle that you know exactly. Well, we know lots of spots exactly, but the easiest spot to refer to is right over here because we have pi radians is equivalent to 180 degrees. And that is nice because you don't have a fraction in the radian measure. That's why we use it. You could think of 360 degrees and 2 pi, but we can reduce that to this pi and 180 degrees. You can set up a ratio and proportion degrees to radians equals degrees to radians, and you can solve that. I like doing that because that's a good conceptual piece, but there's a nice slick formula to go from degrees to radians. And so to find radian measure, you're going to multiply your degree measure times pi over 180 degrees. Now this is pi radians over 180 degrees, and you can see that we'll have a degree in the numerator, a degree in the denominator, and they'll cancel out, and we'll be left with radians. So if we multiply degrees, our degree measure, times pi over 180. So if I multiply this times pi divided by 180 degrees, those degrees cancel out. And I am left with, this is like 55 over 1. Remember that multiplying fractions, you multiply across the top and across the bottom. So 55 times pi over 180. And now we're in radians because I had radians up here. Pi radians. Now this is 55 pi over 180 radians. Now when we're in radians, we like to have pi's in there. It helps us break up that circumference with the radian measure. And so it helps me know, am I in the top half of the unit circle or the bottom half? But this 55 over 180 is a little clunky and it can be reduced. And so I'm going to take 55 divided by 180. And I could do this decimal here, but that's not very helpful. I like a fraction. So if you press the math button and then that first option is frac, change that into a fraction. It will reduce that fraction for you. We want pi in our answer. So this reduces to 11 pi over 36 radians. All right. That's how we go from degrees to radians. Multiply by pi over 180. Let's try a second example. All right, let's try 100, let's do 232 degrees. If I want to change 232 degrees to radian measure, I'm going to multiply by pi over 180. Remember, it's pi radians over 180 degrees, and those degrees are going to cancel out, and I'll be left with just radians. Multiply across the top. Multiply across the bottom. And I'm going to reduce this fraction. 232 divided by 180. I can send it right into the fraction right away. And that becomes 58 over 45. So 58 pi over 45 radians. And that's how we swap. Sorry, camera's moving there. That's how we swap from degrees to radians. All right, let's see if we can go the other way. Can we go from radians to degrees? Well, the nice thing here is you take your radian measure, and instead of multiplying by pi over 180, you're going to multiply by 180 over pi because the top is degrees, the bottom is radians. Those radians will cancel out and you'll be left with degrees. So if I want to figure out how many degrees is 3 pi over 8 radians, I'm going to multiply by 180 over pi and see those radians cancel out. Whatever you want to be moving towards needs to be in your numerator so that the degrees here takes over. And notice that my pi cancels out as well, a pi on top, a pi on the bottom. And so I have 3 times 180, which is 540 over 8. And this will be degrees. 540 divided by 8 is 67 and a half. So 3 pi over 8 radians is 67 and a half degrees. So nice. Let's try one more or 2 more. What if I have 6 pi radians and I want to change that to degrees? I'm going to multiply by 180 over pi. The pi's cancel out. And I've got 6 times 180, which is 1,080 degrees. So if you are moving from radians to degrees, multiply by 180 over pi. If you are moving from degrees to radians, multiply by pi over 180. That one spot on the unit circle that is easiest to move from. One more. What if I have 12 radians? 12 radians, you say? How can you have 12 radians? There's no pi there. Remember that a radian is just the length of the radius. So I can have 12 lengths of the radius, and I will handle it the same way. Take 180 over pi, multiply by my 12 radians. There's no pi to cancel out. So I'm just going to do most of it here on my calculator. I'm going to do 12 times 180. That's 2160. Then I'm going to divide by pi. And it becomes 687.55. And there is my degree measure. All right. So we're able to go from radians to degrees. We're able to go from degrees to radians. There's just one last thing I want to show you, and that is looking at an arc length. That would be like a radian measure, but on a circle that is not the unit circle. What if we have a circle? Ooh, that's not a bad freehand circle right there. Here's the center. And let's say I know that this angle right here is 2 pi over 3 radians. Okay? But I also know that this radius, we're not on the unit circle, but the radius is 16 inches. Okay? I want to find this arc length. That one right there. Well, I know that that arc length, that intercepted arc, is 2 pi over 3 radians. Doesn't matter the size of the circle, whether it's a unit circle or here we've got a radius of 16 inches. It is still 2 pi over 3 radians because this is a unit of measurement based off of the radius of the circle. Well, if I want to know the length of that intercepted arc in terms of inches, I need to remember that each radian is the length of the radius. Well, the length of the radius is 16 inches. So I can take and say each radian is 16 inches. That becomes the unit then, and I have 2 pi over 3 of them. So if I multiply 2 pi over 3 times 16 inches, which I'm not going to do that in my head, I'm going to use my calculator. So I have 2 pi divided by 3 times 16. That gives me 33.51 inches. I've now changed the unit of measurement of that arc length from radians to the same unit of measurement as the radius, inches. So it's 33.51 inches. All right, one more example with that arc length. Let's see if I can draw another circle. Not bad. Okay, let's say that we know that this central angle right there is pi over 4 radians. But I want to find this length. Okay. And I also know that the radius is 12 feet. I'd like to find this green arc length in terms of feet. Well, we want to take whatever this arc is in radians and multiply it by 12. But what is that? All the way around is 2 pi. So if I take 2 pi radians and subtract off pi over 4 radians, I'll get this arc length. Some of you might be like, well, I can sort of visualize that on the unit circle. If you can't, that's okay. Let's just change that into fourths. 2 pi is 8 pi over 4 minus 1 pi over 4. That's going to be 7 pi over 4. And if you picture that unit circle, and we're subtracting off, right over here is 7 pi over 4, and that reference angle was pi over 4. So this angle, this central angle, is 7 pi over 4 radians. So 7 pi over 4 radians, but each radian is 12 feet. So I will multiply those. So we really have, I can divide both those by 4 and I get 3. So this is 7 times 3 is 21 pi feet. Well, I don't think in terms of pi very well. So what is 21 pi? So we've got 64.97 feet is that green arc length. All right, and there we go. So today in your homework, you will be taking degree measures and changing them into radians. We do that by multiplying by pi over 180. And then we will be taking radian measures and changing them into degrees. We do that by multiplying by 180 divided by pi. And then looking for some arc lengths. So you'll find your homework on Classroom. Email me any questions, and we'll see you soon.